Okay, so for the second set of examples, I believe this is question 18 and or 19 and 20 on the exam 3 study guide. We're going to do the first natural log question, and then we're going to do this one. So for this one, what we're going to want to do is, since they're being added together, we're going to multiply x and x plus 8. Since the logarithm rules, natural logarithms behave the same way. So since both of these have base of e, we can rewrite it as ln e x times x is going to be x squared plus 8x. And then we're going to set that all equal to 4. Now once you're at this point, in my last video, the solving basic logarithms, you can either rewrite it using that method, or you can rewrite it using a method where you set both sides to the power, or you set e to the power of both sides. So essentially that would look like e to the power of this over e to the power of 4, and this would cancel out, and you would be left with x squared plus 8x equals e to the power of 4. But if you don't like that method, you can also do the ln e x squared plus 8x equals 4. You can do how it's e to the power of 4 will equal x squared plus 8x. So it's essentially, it comes out to be the same thing, but e to the power of 4 is equal to x squared plus 8x. It's sort of just a visual form of being able to write the equation. So once you're in this form, you want to get everything to one side and set it equal to 0, since you have an x squared term. So you want to subtract e to the power of 4, subtract e to the power of 4, so you're going to have x squared plus 8x minus e to the power of 4 is equal to 0. And since this isn't something that's factorable, we're going to go and we're going to have to use the quadratic formula, which, if you don't remember it, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you don't remember how to apply that, essentially if you have an equation, say, let's just say a simple one, x squared plus, or 2x squared plus 2x plus 2 is equal to 0, you would set it as this is the a, this is the b, and this is the c. And if this was a negative sign, let's say this is negative 2, you need to take into account the negative sign. So you'd put in negative 2 as the c. So in this case, in our equation, our a is essentially, it's going to be 1. Our b is going to be 8, and our c is going to be negative e to the power of 4. So we can rewrite that as negative 8 plus or minus the square root of 8 squared, which is going to be 64, minus 4 times a, which is 1, times c, which is negative e to the power of 4, all over 2a, which is 1. Now if we work that out, we're going to end up with negative 8 over 2 plus or minus the square root of 64 is 8. So, or actually, let's not do that yet. So we're going to have 64 minus or plus 4e to the power of 4 all over 2. And it's that because since we have a negative 4 times 1 is negative 4, and then negative 4 times the negative e to the power of 4 is positive 4e to the power of 4. So that's why we ended up with 4e to the power of 4 and then 64. So once we're in this form here, negative 8 divided by 2 is going to be negative 4. So you're going to have negative 4 plus or minus. And since this is addition, you cannot take the square root of 64 and then take the square root of whatever this is. So you can't just take out an 8 and then leave, you can't take out an 8 and then take out a 2 and leave the e to the power of 4. Since it's addition, these two are essentially connected. So whatever you take out of one, you need to take out of the other. And if you can't take 8, since you can take 8 out of 64, you can't take 8 out of 4. So the greatest common factor between these two for a square root is 2. So you can take or it's actually 4, but it comes out to be 2. So let me just show you. So it would end up being, when you take out 4 from 64, it's going to be 4 times 16. That's essentially the same thing as the square root of 64. And then in this one, you can take out a 4, so it's going to be the square root of 4. So you're going to be left with, since you take a 4 out of both, the square root of 4 is 2, so plus 2. And then you still have the 16 inside, and you still have the e plus 4. And you can't take the square root of 16 since it's connected to the e to the power of 4, unfortunately. And then this whole thing is still divided by 2, but that's going to cancel out. And then you're going to be left with negative 4 plus or minus the square root of 16 plus e to the power of 4. And again, you cannot leave it like this. It's either the positive one or the negative one, since we have bases. And if you check, you have to check back. So I guess plug it into your calculator. Negative 4 minus the square root of 16 plus e to the power of 4 does not work out. It ends up being an overall negative sign, so it's not going to work out. So the positive one is the only one that actually works. So your answer is going to be x equals negative 4 plus the square root of 16 plus e to the power of 4. And I know that was quite confusing around this part. So I apologize if I wasn't the best at explaining. So if you have a question about that, you can just leave a comment, and then I will get back to you as soon as I can. And now for this equation. So for this one, what we're going to want to do is, since they all have the same bases, we can combine them all. So for this one, since it's a negative sign, these two, it's going to be x plus 6 divided by x plus 2. So it's going to be log base 3 x plus 6 divided by x plus 2. Since addition is multiplication, subtraction is division for logarithms, and then it's going to equal log base 3 of x. Now since these have the same bases, you can set this equal to x. So it's going to be x plus 6, x plus 2 is equal to x. And now once you're at this point, you're going to want to get rid of the x plus 2. So you multiply both sides by x plus 2. So that's going to cancel out. And then when you do this guy, he's going to be x squared plus 2x is going to be equal to x plus 6. And I'm sure you can recognize, since you have the squared term, this is going to be a factorable equation, or at least a quadratic formula equation. So you want to subtract 6, subtract x, that way we get 0 on one side. So we're going to have 0, we're going to have x squared plus x minus 6. And you cannot, unfortunately you can't factor this out, so you're going to need to use the quadratic formula. So again, it's going to be negative 1 plus or minus the square root of b, which is 1. So it's going to be 1, because 1 squared is 1, minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1, so it's going to end up being 2 again. So we're going to end up with negative 1 plus or minus 4 times 1 is 1, 4 times 6 is 24, negative, negative, so it's going to be a positive. So we're going to have 1 plus 24 all over 2. So then this comes out to be negative 1 plus or minus the square root of 25 over 2, which is quite a nice number. So if we rewrite that up here, the square root of 25 is 5, so it's going to be negative 1 over 2 plus or minus 5 over 2. And then now, since we have that, we should be able to work it out. So I guess we'll do it right here. So negative 1/2 plus 5 over 2 is going to equal 4 over 2, which is going to equal 2. And then negative 1/2 minus 5 over 2 is going to equal negative 6 over 2, which is going to equal negative 3. So your two answers are x equals 2 and x equals negative 3. Now let's check if that actually works out in the equation. So if we plug 2 in, we're going to get 8 and we're going to get 4. So that one checks out. That one's all good. And then negative 3, 6 minus 3 is 3. Negative 3 plus 2 is negative 1. So unfortunately it can't be negative 3. So your answer for this problem is going to be x equals 2. And I believe that was all 4 of the complex logarithm equations. So yeah, if you have any more questions, just feel free to ask. If you'd like me to cover a certain topic, or if I didn't do a good enough job explaining in this video, just mention it and I'll try to do my best in another one. And thank you guys for watching.